Hello everyone, welcome back to another video. Today we're going to be looking at the November 2024 paper, and we're going to focus specifically on the section on electricity. Okay, so let's go through the questions. Question 1.7, the graph of current versus potential difference obtained for 4 different resistors J, K, L, and M are shown below. So we've been given these graphs and they want to know the resistor with the largest resistance is what? Is it J, K, L, or M? So we need to think of the equation for Ohm's law, right? And the equation says that R is equal to V over I, right? So if we have a graph of voltage on the y-axis and current on the x-axis, and we work at the gradient of this line, the gradient would give me the resistance. Okay? But if you look at this graph that they've given us here, we have current on the y-axis and potential difference on the x-axis. So basically what we have now is we have I divided by V. So this is our main equation. If V over I is equal to R, that means I over V will equal to 1 over R. So for this graph, the gradient is 1 divided by R. So how do we figure out which one has the largest resistance? So it's actually going to be the opposite of what we normally would think. Normally we would say the steepest is going to be the greatest resistance. But since the gradient is 1 over R, it's going to be the one that is the least, how do I say it? The least steep. That's going to be the one with the greatest resistance. So through just inspection, the answer is going to be L. So L will correspond to letter C. Next one, 1.8. Different combinations of the same 4 identical resistors are shown below. Which one of the following combinations will have the highest resistance? Here, the easiest way would be to just substitute a value. That would, like, in my opinion, that would be the easiest way. But instead of doing it that way, let's work it out in terms of x. So let's test A. So let's assume that each one, let's call it x, 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 and x. So since they're all in parallel here, we will say that 1 over R parallel is equal to 1 over x plus 1 over x plus 1 over x plus 1 over x. That's equal to 4 over x. That means R parallel is going to equal x over 4. So the effective resistance for A is actually going to be 1/4 of x. Okay, let's do B. So let's call that x, let's call that x, x, and x. So actually, let's do it here. So here we can say 1 over R parallel is going to equal 1 over x plus 1 over x. So then R parallel will equal x over 2. So this is going to be, so this part here, let's just highlight it. So this here is going to be x over 2. And since they are the same, this one here will also be x over 2. And they are in series, so your total here will be x. right? So this one has an effective resistance of X, this one has an effective resistance of a quarter X. So far B is looking greater. Let's consider C. So if that's X, and that's X, and that's X, and that's X, we already know what this will be. That's going to be X over 2. So that's going to be X plus X plus X over 2. That's going to be 2.5X. So C is currently looking promising. All right, let's look at D. If that's X and that's X, that's X and that's X, we add these two, so that's going to be 2X. We add these two, that's going to be 2X. So 1 over R parallel is equal to 1 over 2X plus 1 over 2X. That's going to be 2 over 2X. That means R parallel is just going to equal X. So quite clearly we can see that the greatest one is going to be C. Again, easiest method would just simply be to substitute some value, right? But I wanted to do this X method so that you can see how it simplifies, right? But again, it doesn't matter, whichever one you choose. Question 1.9. A circuit is set up as shown in the diagram below. The EMF of the battery is 12 volts. The voltmeter reads 4 volts and 10 volts as shown below. The battery has no internal resistance and the resistance of the conducting wires can be ignored. So I actually answered this before, but let me show you how we work this out. So we know that the total voltage is 12, meaning the voltage used up by each resistor must equal 12. So if these two are using up 10, it means that this one here should be using up 2, right? Because 10 plus 2 will give me 12 volts. And if these two are using up 4, it means that this one must be using up 8, right? Because 8 plus 4 is 12. So that means the one that's left is this 4 ohm. This 4 ohm must therefore be using up 2 volts. And if we add it, we can of course confirm this. 2 plus 8 gives me the 10, and then 2 plus 2 here gives me the 4. So they want to know what is the value of resistor X. Since resistor X is also using up 2 volts, that means it should be 4 ohms as well, right? Because remember, the 4 ohm resistor was using up 2 volts, so that means this 2 volts should be across another 4 ohm resistor. Okay, let's move on. 8.1, P, Q, and R are light bulbs with the same resistance. They are connected to a battery with EMF E and negligible internal resistance as shown in the circuit diagram below. Okay, how does the brightness of bulb P compare to that of bulb Q? Choose equal to, greater than, or less than. Give a reason for your answer. So I'll show you a few ways. You can of course choose whichever one you prefer. Remember, brightness, when we talk about brightness, we're usually referring to power, right? And power is equal to V squared over R, or you can also do power as I squared R. There are other equations, but these are the ones I'm going to focus on for now. Now, remember, if you look at this connection, the way that this thing is connected, this is a parallel connection, right? It's a parallel combination, meaning that the voltage is going to be equal, right? The voltage is going to be the same. So the voltage here, this voltage is going to equal this voltage, and it's going to equal the EMF of the battery, right? But more importantly here, this bulb P is actually going to use up half the voltage, and this one here is going to use up half the voltage, right? Because it's shared, right? Whatever value, whatever voltage is being used up by that branch is going to be shared between those two bulbs. Whereas if you look at R, bulb R doesn't have to share it among anything. Okay, so this is actually the first way that you can look at it, but I'll show you the other way as well. So they want to know P and Q. So we'll say that P and Q will actually have the same. They will be equal, right? And the reason why they are equal is because the voltage is the same, right? We don't know what the voltage is, but we know P will use up half of it and Q will also use up half of it, right? So half V, whatever V is, it's half. So the power will be the same because the voltage is the same. Now, if you consider next one, how does the brightness of bulb P compare to R? So if you look at P and R, P uses half V, whereas R uses up V. So R is actually going to be brighter. So how does brightness of P compare to R? It's going to be less than. Right? And then why is it less than? It's because the voltage or potential difference is lower. Okay? So that's obviously one way of doing it. Let's look at another way of explaining it. So what we can do is we can think about the current. How will the current that flows through these branches look? So remember, if the current is flowing this way, right, the current is going to split. So it will split in this branch, and then it will split in this branch here. And then they will join back up and they will go here. Now, since all the bulbs are the same, right, let's assume that this is 3 ohms, then that might be 3 ohms, then that might be 3 ohms, right? We know that current takes the path of least resistance, right? So we can say that it doesn't matter what the current is, but we can say that more current will go through here than will go through this branch, because this branch has a resistance of 3, whereas this blue branch has a resistance of 6. So current will take the path of least resistance. More current will go through the green branch than it will the blue branch. So you could also explain it that way. You could say, how will the brightness of P compare to that of R? You could say that P will be less than, so this is again 8.1.2. It would be less than because less current passes through it. Okay, so you have two options. Doesn't matter which one you choose, the outcome is the same. Okay, let's move on. Question 8.2. A battery with an unknown EMF and negligible internal resistance is connected to 4 resistors. A high resistance voltmeter, 2 switches, and 2 ammeters of negligible resistance shown below. Both switches are closed. A1 in 1.2 amperes. Okay. Calculate the reading on the voltmeter. Okay. So what do we know? We know that the voltage in this branch is going to be the same as the voltage in this branch, because remember, voltage in parallel is the same. So what we can do is we can say that the voltage in this green branch, V, is going to equal I times R. We've been given the current 1,2, and the resistance is actually going to be 2 plus 5 because they are in series. So 1,2 times 2.5, that's going to be 1.2, and then open bracket That's equal to 8.4 volts. Right, so 8.4 volts. So effectively, this is using up 8.4 volts, and this entire branch here is using up 8.4 volts. Okay, let's move on. Next one, calculate the reading on ammeter A2. Okay, so ammeter A2, this one here, is reading the total current, so IT. And remember, the current was split because of that parallel branch. 1.2 amperes was passing through here. And all we need to do is work out what current is passing through here. And if we add them up, we'll get the total current. So if you look at this yellow branch, we know that the voltage is 8.4. We know the resistance, we can work out the current. So 8.2.2, we can say I equals V over R. 8.4 divided by 3, and that's equal to 2,8. So 2,8 amperes. Now to get the total current, which is equal to A2, it's going to be 2,8 plus 1,2, which is 4 amperes. Okay, what is the power dissipated in the 3 ohm resistor? So 8.2.3. Now, if you consider, we know everything here. We know the current is 2,8 amperes. We know current, we know resistance, we know voltage. We could use any equation and the answer would still be the same, right? So let's just go with the simple one. We'll say power equals I times V. The current we just worked out is 2,8. The voltage was 8,4. And you multiply them together, you're going to get 23,52 watts. If you did another equation, if you said power equals I squared R, you still get the same answer, 2,8 squared times 3. That will also give you the same answer of 23,52 watts. Okay, next one. Switch S1 is now opened while switch S2 remains closed. The reading on the ammeter A2 is now 3.48 amperes. Okay, so let's clear this out. So S1 is opened, S2 is closed. So this is now our circuit. Okay, so that's our circuit. And the current, they tell us the current is 3,48. Calculate the EMF of the battery. So 6 marks, usually 2 calculations or simultaneous. All right? Now, if we consider what we have and what we want, it's most likely going to be simultaneous because if you look at it, we don't know this resistance. And we also don't know this voltage. We don't know the EMF. So there's 2 things we don't know. So if you don't know 2 things, you're going to need to use a simultaneous equation. So let's look at how we can work this out. So let's look here, 8.2.4. Now what do we know? We know that the voltage that's being used up here, like whatever that voltage is, right, plus the voltage that's being used up here is going to equal the total voltage, right? That's a basic principle of how the voltage gets distributed in series. Okay, so what we can do now is we can create an equation, right? We can say that the total voltage is going to equal the voltage that's being used up by R plus the voltage that's being used up by the 3 ohm resistor. Okay, now we don't know the total voltage, so let's call it VT. And let's look at the voltage that's being used up by R. We know that voltage V is equal to I times R. We know the current that's passing through it. The current is 3,48. So this is 3,48 multiplied by R. We don't know what R is. And then plus the voltage used up by the 3 ohm resistor is actually going to be 3,48 multiplied by 3. Because remember, this whole circuit now is in series. So the current is the same. So Vt is equal to 3,48 R plus, and 3,48 times 3 is 10,44. So that's equation number 1. Now equation number 2 is actually before the change. All right? So let's look at what happens before the change. So that was equation 1. We got equation 1. Let's look at before the change. So before the change, this was our entire circuit, right? So let's put some color here. And let's use this. All right. Now we can do the same thing here, but just slightly tweaked. The voltage here by the battery, right? The EMF of the battery, it's going to be distributed in 2 areas. It's going to be distributed here, just like before, and it's going to be distributed here to this parallel combination. So what we can do is we can say for equation number 2, we can say that Vt is equal to VR, so the voltage that's being used up by R, plus V that's being used up in the parallel combination. Now before the change was made, we knew the current was 4 amperes, right? And we also knew the voltage that was being used there. The voltage was 8.4 volts. Remember, we worked it out here at the top. So what can we say? We can say that Vt is equal to 4 times R plus 8.4. This is actually now equation 2. So we know that the voltage is the same. So we can equate them. Equate 1 equaling 2. 3.48 R plus 10.44 equals 4R plus 8.4. Now I solve for R. R equals 3,92 ohms. Now you take this value and substitute it either in equation 1 or equation 2. Doesn't matter. So let's substitute it in equation number 2. So we'll say Vt equals 4 times 3,92 plus 8,4. And that gives us a voltage roughly 24,08 volts. And that's our answer. Okay. Let's move on. Switch S2 is now opened while S1 is closed. Okay, S2 is opened. Let's clear this. Okay, so S2 is open, S1 is closed. This is our circuit. Right, so that's our circuit. They want to know, so this is out. So they want to know, how will the reading on A1 change? So A1. Choose from increase, decrease, or remain the same. All right. So let us consider what would happen. Okay. So when let's do this. I think it'll be easier if we do it like this. When this was our circuit, what was our resistance? So let's compare. We'll compare them, right? So when S2 is closed. So when S2 is closed, so let's write it out here. S2 was closed. My R total was 3 plus R. And we worked out R was 3,92. So 3 plus 3,92, and that's 6,92 ohms. But then when S1 is closed, this is now the current question that they're asking us. Let's look at what happens. This is our new circuit. Our total resistance is 2 plus 5 plus R. So my R total is 2 plus 5 plus 3,92, and that's 10,92 ohms. So what happened? So R total, you can see here, R total has increased. Okay, so we look at our equation. R equals V over I. Since the voltage is the same, R is inversely proportional to I. So if R increases, I will decrease. So if R total increases, I total decreases. So they want to know what's going to happen to A1. A1 is reading the total current, so A1 will decrease. That's our answer. Okay, let's do the last one. Last question. An electric heater draws 4.4 amps from a 220 volt source. Calculate the cost of using the heater for 30 days if the heater is used for 3 hours per day. The electricity tariff is 1,83 rands per kilowatt hour. Okay, so the cost of using an appliance is equal to the rate multiplied by the kilowatts multiplied by the hours of usage. So they tell us the rate is 1,83. The kilowatts, so we don't know the power, but we can work out the power. If you look at the information they've given us, they told us 4.4 amps and 220 volts. Power is equal to V times I. If I multiply those two, I'll get the power. Okay, so let's do that. So power is equal to V times I. Power is equal to 4.4 multiplied by, actually it's the other way, 220 multiplied by 4.4, and that gives us an answer of 968 watts. Now, remember we want kilowatts. So 1 kilowatt is 1,000 watts. So 968 watts is going to be 0,968 kilowatts. So here we're going to substitute 0,968, and the number of hours is 3 hours per day, and then 30 days in a month, or for 30 days. So you multiply all of that together, and then you get a total cost for the month, 159 Rand and 43 cents. Okay, that's it. If you like this video, please leave a like. If you'd like me to do something specific or a specific paper, please let me know in the comment section below.